yahoo.com. So if you observe this little lock here, and if you observe this HTTPS sign, that our traffic is secure, encrypted. How it is encrypted? Because Yahoo is using this digital certificate. Someone issued this certificate, and what certificate is, why we need certificates, how we generate certificates. So we can see so many things. So the certificate tells it all. It is assigned, it is the certificate authority is DigiCert. So let's go to the theory first, and then we can. Information security goals. We will eventually reach to PKI, but first of all, what's information security? So there are three goals: confidentiality, integrity, and availability. Like if I am sending a document to someone, I mean, if it's a confidential document, so I want that nobody else can read it. We am talking about physical word, no digital, nothing digital there. I just want a mechanism that this confidential document reaches to someone who is an intended person, and anybody else cannot get it. Or if he can get it, he cannot read it. Like in World War II, there were keys available that, I mean, I don't know how it was done, but there was some secret box available. The even someone gets it, it cannot understand what is written in there because there was a way to decode it. The second important thing is when you send someone a letter or file, it should not be tempered. So there were seals available to make it the integrity of the document and the availability. So whatever you wanna get it, it should remain available. That's availability. That is simple. So everyone, maybe in your life, maybe you have heard the word cryptography. So what is cryptography? Cryptography is like mathematical functions. They are the algorithms. When you send some data to that function, it encrypts the data, and you cannot view the data anymore. Like in your Windows laptop, you have BitLocker. You have a key to that BitLocker. If anyone has the key, he can open the hard drive. Otherwise, he cannot open the hard drive. So you can have so many scenarios of cryptography. So cryptography is a way of protecting sensitive information as it is stored on media or transmitted through untrusted networks. So if you are sending an email and you are sending some important document and your mail is not encrypted or your document is not encrypted, maybe someone sitting in between can sniff your traffic and will get all the data what you are sending to someone else. So cryptography encrypts the data, and he encrypts it with the key. So let's go with the flow. Okay, cryptography is used for achieving confidentiality, integrity, non-repudiation, and authentication. The two major components of cryptography are, as I am telling you, the algorithms and the keys. And the key add randomness and uniqueness to the output of the algorithm. So now cryptography objectives. As I was telling you, first thing is confidentiality. Second thing is integrity. Third thing is non-repudiation and authentication. So we know the confidentiality, we know the integrity. What is non-repudiation? If I am signing a contract paper, so the document is there and we sign it. Maybe if it is very important document, maybe we will be using our thumb impressions. I'm talking about the old days. So I am using the thumb. I am using the signature so that I cannot deny that this was not me. So this is non-repudiation. We are now living in a digital world. So we have to have a mechanism that if I am signing the document digitally, or if I am sending some document and or if I'm sending an email, so I should own it. And there is some mechanism that if so that I cannot deny it that this is not sent by me or I haven't said this. So that's called non-repudiation. So we have to ensure this in today's world. So cryptography does that. How we are gonna do that? We will. I will explain it in few minutes. Authentication. Let's say sender and receiver can confirm each other's identity. So let's say if I am sending you a mail, so you should know that I am sending the mail and nobody else is sending the mail. Maybe I am sending you very important information, and maybe this is a wrong information, or this is very high classified information. So you should know that if I am sending the information, maybe someone is not using my name or my signature to send you the email. Or maybe if your boss send you the email that you got a bonus, or you are invited for lunch today at a very expensive hotel, and you reach there and nobody is there. So you should know that if he has done the email or someone else has sent the email just to misguide you or irritate you. I'm just giving the layman examples here. So the encryption solves all of these problems. How it does, we will see. Okay, its general theory encryption addresses confidentiality in the CIA triad. What is CIA triad? So encryption addresses the confidentiality in CIA triad. It is the process of changing information in such a way to make it unreadable by anyone, and only those possessing special knowledge. That is the key that allows them to change the information back to its original or readable. So why encryption is needed? Securely protect data, to protect corporate secrets. Government use it to secure classified information. Individuals use it to protect personal information. That's just general. Now this is important: hashing or message digest. What is hashing? It's a very unique algorithm. This algorithm will solve the one problem: integrity of a document. If I have data of 1 kilobyte or I have data of 1 terabyte, this hashing algorithm is very fast. It will just create a hash of that document. I mean, uh, and even if it is 1 terabyte, the hash will be few bits. If it's 1 kilobyte, the hash will be few bits. And if you run on that 1 terabyte document, this algorithm, again and again, the output will be the same. And if you add a single space to that 1 terabyte document, single space, a comma, you delete a space, the output will change. So it is not possible that you have a document which has 1,000 pages, and if someone adds a single comma, it is very difficult to find it. But this hashing algorithm, even if one comma is added, the hash is changed, and you know the data has been altered, so the integrity of the data is gone. So this is hashing. So the hashing solves the problem of integrity. Let me show you an example. It is deterministic, so that the same message always results in the same hash. It is quick to compute the hash values of a given data. These are the characteristic. It is not possible to generate message from its hash. Of course, you have few strings, a small string available. How you can generate a complete data with that string? This is not possible. And I can show. I will show you in the next slide. And I told you it is highly not likely or unlikely to find two different messages with the same hash value. I don't know whoever has designed this algorithm. He has done it so perfectly. So if the word fox is the input, if you apply message digest or hashing, the output will be this hash. Now the red fox jumps over the blue dog. The content is increased, but the hash size will remain same, but it will be different. If you observe the spelling of over, it is over here, and it is our here. The human brain process the words by reading the first and the last word and few words in between. So if you're reading it, you will not even observe it that it is not we, it is not you, it is we. But you know the cryptographic function has changed. It was 0086, now it is 8FD8. So just changing a small character will completely change the hash. Even if you do OEVR, the spelling is wrong. Just the hash is totally changed. FCD3. If you skip V, the hash is again totally changed. So this hashing algorithm, and if you will run it on this red fox jumps over the blue, if the or you are running on the original document again and again and again, it will be the same hash. So if you receive a document, if the sender is sending you some document, he will send you the document and he will send you the hash. If the hash is the same as the document, then the document integrity is intact. If the hash you are generating doesn't match, which means the data was altered in between, so you should not trust that data. So hashing is a mechanism. Okay, hashing is a mechanism to achieve integrity. Now let's say I want to send you a file. I should encrypt the data with some key. Just like if I want to send you something and I have in a box and the box is key protected, I have a physical key available. Now if I send you the box, you should have the key to open that box, and only you and I should have that key available. If there is someone in between who has the key, so he can open the information. So of course, if I'm sending you the box, so I'll make it sure that I have the key and you have the key. Now if I am sending the data electronically, I'm sending the document electronically, what should we do? Okay, I have a key which can be a password, 4-digit key for 5-digit password. So I will send you the email, I will send you the document, and I will tell you the password. Okay, this is the document, this is the password, this is the PDF file. I have encrypted it with this password. So when you receive this file, open it with this password. But the problem is, whenever I'm sending someone a document, I have to call him or text him, because you cannot send the password in the email, because if someone is sniffing your data, of course he will sniff the encrypted data plus your key. So he will get your key. So you would send the document from one channel, like you can email it, and you can text the key from your mobile network, or you can do WhatsApp, or you can, if it is very confidential, you can call him. So it is very fast. Let's say clear text was hello, encryption is applied. This is, oh come on, this is the encrypted data. The receiver has received the data and it has applied the same key, and he has the actual text available now, hello. And symmetric key encryption, the beauty of symmetric key encryption is this encryption and decryption is very, very fast, but it has a challenge. The key sharing mechanism is very difficult, because if I want to send data to two people, so I have to share my key to both of them. Let's say I have 10 people available. I have to share the data to 10 people. So now I have to send that key to those 10 users. Now, if they want to send, and if I want to send them some data to next 5 people, so I should have the keys of those 5 people also. So managing keys is like, how I'm gonna distribute the keys. If you have 3 people, the 3 keys are required. If you have 4 people available, you need 6 keys, and if you just have people available, you need 15 keys. So to communicate, let's say I want to communicate with you, but I don't want anyone to know the information. So for 10,000, so 1,000 people, 5,000 keys are required. So how you're gonna remember which key belongs to what? You will all day you will be searching for the keys. Okay, I want to send back. Let's say I want to send Bob some data. I want to send Alice some data. So first I have to find the keys of the Alice and Bob, and there is a huge chance that I can mix up the keys. So this is the mechanism. This was the problem with symmetric key distribution. So then there comes the concept of, to solve this problem, we have the concept of asymmetric keys. You have a private key, and this is the most widely used concept. This HTTPS browser, this is using a key pair, private key and public key. It's a key pair mathematically related. You can encrypt from private key and open it from public key. You can encrypt from public key and open it from the private key. Okay, the beauty of this concept is I am the owner of the data. So I'm the owner of the key. So I will have my private key with me always. I cannot share it with anyone. And I will use my public key I can send it, okay, everybody can have my public key. I don't care. Because whenever I will distribute it to everyone, okay, this is my public key, it is already public, you can have it. But when you will be talking with me, you will be encrypted data through my public key, and nobody else can decrypt it other than myself using my private key. This concept is very important. You are getting it or not? So the plain text goes through the public key and it becomes the ciphertext. And cipher can be decrypted back to original text using my private key. And using public key, you cannot regenerate a private key. That's not possible. So both keys are different, but mathematically related. Private keys kept securely and public keys distributed. Using the public key, private key cannot be reproduced. I explained this. Encrypt with one key, decrypt with the other key. And asymmetric encryption is slower than the symmetric encryption. Okay, this is the problem with the asymmetric encryption, because the algorithm is intense and it takes a lot of CPU cycles to decrypt your data. But it solves one problem, that the key distribution is much easier. So with symmetric key, the decryption encryption was fast, but the key sharing was a problem. With asymmetric key, the key distribution is easier, but the cost is a bit high. And here I am just discussing RSA, DSA, Diffie-Hellman. These are the algorithms for asymmetric keys. And we are mostly using these days RSA. Okay. It is too much theory, so you will be distracted. So I want to ask, okay, who is there? Can someone tell me, if Alice wants to send the data to Bob, from which key it will encrypt the data? Hello? Public key. And
Yes.
that key is publicly available. Do we agree?
Yes.
So Alice has the keys of everybody in the world. So whenever she wants to communicate to anybody in the world, let's assume she has the public key of everyone. So if she wants to talk to Bob, Alice will have the Bob's public key. If Bob wants to talk to Alice, so Bob will have the public key of Alice. So whatever she's sending, Bob can decrypt it. Whatever Bob is sending, Alice can decrypt it. So this makes it so perfect that the communication is done and the key sharing mechanism is not a big problem. And I have the public key of everybody in the world in my laptop. Let's assume that and let's move forward. I explained you, if Alice is signing, or if the data is signed by a private key, if I am encrypting my data with my private key, if I can send this data to anyone and he can decrypt it with my public key, so it means that the data is what? This is like you are putting your signature there. It's like you are putting your thumb impression on that document, because if you are encrypting it with your private key, it can only be decrypted with your public key. And everybody knows your public key. If it is decrypted with your public key, you cannot deny that you have not signed this document or you have not encrypted this document. Do we agree on this?
Yes, understood.
So if I am signing with my private key, only it will be decrypted with my public key. So this is the document signing. Every organization have their private key very securely somewhere placed, and they digitally sign with their private keys of that key pair. And everybody who is decrypting that document publicly trusts that document, because this document was signed by the organization's private key. How the trust is established, we will see it later. But seems like our data signing or data authenticity, I mean the integrity is different thing now. The signing is also achieved by asymmetric keys. Okay, we all know the problem of now we all know the benefits, advantages of the symmetric key. It is very fast. Asymmetric key, the public key, is very uh, easy to distribute. If we want to use both algorithms together and we want to have the advantage of both the algorithms, so what was the problem with shared key?
We had to
We have to share it with
duplicate
everybody
with everyone. Yeah.
securely through some other channel, through some call, text, phone. But now let's say I can send the key to Bob using public private key. So what I'm gonna do is I am gonna send the key by encrypting it through Bob's public key, and only Bob can decrypt it, right? Okay, this is very fine. Alice is sending a shared secret key. I'm talking about symmetric keys, not asymmetric keys. I'm trying to use both. So if Alice has a password, let's say 123, she encrypts it with the Bob's public key. So we agree that only Bob can decrypt it, right?
Yes.
So Bob has the key 123. If someone is sitting in between, he or she cannot decrypt the data. So now Bob has the key available. Because Alice is sending the key 123 and Bob is receiving the key 123, so now they can share the data and they can do a symmetric key decryption encryption, which is very fast, and the key distribution problem is solved.
Got it.
Got it?
Yes, got it.
So this makes a perfect life that the key is shared, the encryption is very fast. So asymmetric key solves the problem of like the security of your key. But there is a problem. If I want to know your public key, of course, either you will send it your public key to me through some mechanism. How do I trust that this is your public key? Maybe there is some other guy who has generated a public the key pair, and he is pretending you and sending his own public key to me, and I can encrypt the data with the public key and he can decrypt it. So how do I trust that this key belongs to this guy? That's a problem.
Mhm.
And how to find keys of everybody in the world? I mean, I want to talk to you right now. Let's say I want to communicate with you. How do I get your keys? How I get, how can you I can get your public key? It is supposed to be public, but how to trust that public key and how to get that public key? That are two basic problems right now. We know what the algorithms asymmetric and symmetric does, but now the problem is the authenticity of the key. For that, this public key infrastructure came into existence. What's a public key infrastructure? It is a framework including software, hardware, infrastructure, standards, policies, and so much allows the issuance and distribution of cryptographic credentials like key pairs. I'm not going into theory. Let's know what's a certificate authority. So certificate authority is an organization who is trusted by the people, who has gone through some audits, and there should be a trust that this organization, whatever they are saying, we trust them. And everybody submits their public key to that organization. And that organization on somehow stamp your key that it is the original key and it belongs to you. There is a mechanism, of course, that that certificate authority will ask you some of your credentials. You need to verify who you are. Maybe you are taking your driving license or your any national identity card, which is provided to you by your, I mean, government, and you cannot fake it. I mean, I cannot. Let's say if you are going for driving license, maybe some documents are required there. I mean, we go, we need the for driving license, even because driving license is what its authority. They are authorizing you to drive your car. Maybe you have some social security number. There is some authority who is issuing that certificate number, and if you say someone, this is my social security card, maybe there is a card there. So can anyone say that this I don't trust you? This card, anyone can produce that card or this driving license. I don't trust the authority who is giving you the driving license. So first we have to establish a trust that this authority, if they are giving the license, so it should be okay. And if it is, whenever I'm seeing the your driving license, uh, I should immediately know that if it is issued by this authority, so it should be true. So it's fine because it is issued by them. So are you getting this concept?
Yeah, I got it.
So if the certificate authority is signing your key, if it is saying that your key is authentic, it means it is authentic. So it is established through some trust. So the trust is very important. That's why I'm saying the server, wherever the certificate authority or PKI root servers are placed, that environment is so much secured, you cannot imagine, the way I was telling you. So then this trust is established, and even some of the setup is placed offline. So it cannot be altered by any means. So the certificate authority, then the offline setup are on special hardware, so that offline data cannot be taken by someone. Even if you tried, if somehow you break into the facility and take that laptop or the device where the keys are stored, the private keys are stored, if you try to open it, it will destroy its data automatically. It will destroy the hard disk. It is better that the key is destroyed rather than it is stolen. So they are placed in special hardware. You try to tamper it, it will destroy the box automatically. The data is gone, everything is wiped clean. So much is thought before implement this solution. Now, let's say you have generated a private and public key pair. Now, what you can do is you can have what we need, that the key which is publicly available, it should be trusted. So that key, I will take that public key to my certificate authority that please sign this key for me so that it becomes a trusted key. If that key is signed by authority's private key, so it will be decrypted by what?
The
Authority's public key.
public, yes, yes.
Yes, if it is decrypted by authority's public key, it means that it is a trusted key. And the certificate authority has, we studied in signing, that if you sign with your private key, only it will be decrypted through the public key. So if it is decrypted with the authority's public key, it means it is signed by the authority, and this public key, your public key, is valid. And everybody starts going with their public keys to the authority, proves it who you are. It is the job of the certificate authority. Just like when you go with the driving license to see you or whatever is the requirement, I mean, I don't know exactly what requirements are there. So they may ask you a picture, they may check your eyesight, they may check a lot of things to give you a license. So the certificate authority will do the same. If you are taking the certificate for your website, okay, they will say prove it that it is your website. Okay, how I'm gonna prove it? Put this document on your server, and we will check the link that if this document is there. If it is there, because I have told you that this document should be there, and if you can put it immediately, so it means it is your website. I mean, you are at least controlling it. So the verification process is the responsibility of the certificate authority. And I'm not going into the detail of the architecture, but there are so many components which make the PKI infrastructure. I mean, if you're signing a document, the document is signed at a particular time. In older days, we just used to write the dates, but in digital certificates, the time is very important. It should be micro, nanosecond, whatever is there, it should be exactly the same, because transaction can depend on it. There's $1 billion transaction that can depend on it. So the concept of time is very important in any PKI. And we use GPS, the physical GPS. There are special devices which gives times through GPS. We cannot take any internet time or machine time. We cannot set it manually. So that's a time stamping server, TSP. So while generating a certificate, the TSP actually provides the time. So it is the exact time I am getting it from the satellite directly. So there should be online data, and there is some offline data also. Uh, Let me see. Okay, not much lights left. So this is a digital certificate. I just checked it from yahoo.com, and it is saying that this is issued to yahoo.com. Organization is oath holdings, and issued by DigiCert. This is the certificate authority, and this is the validity, which is very important. The certificate is valid for some period. So it was issued on May 2, and on October 6, this will expire, and they will have to renew it. And this is the fingerprint Shaw of your certificate. And let me. So I was telling this is the certificate of Yahoo.com. It is publicly available. You can see it. You can see that so much information is there. US, California. It's the certificate of Yahoo.com, provided by DigiCert. Common name, expiry date, validity. Validity is the most. Which is this is the this is a wildcard actually certificate. Whatever comes before Yahoo, this certificate is valid. And algorithm they are using elliptic curve, sorry. And you can download the certificate. It's a public certificate, so there's no problem. You can download it, but you cannot open it in a text file. So let's try to download it on a desktop, or let's be in my downloads. And if I want to open it, I can open it like that. It's the certificate. It's the key. Oh, sorry, you cannot see it. I have to share it. Notepad. So this is the public key. We are not talking about 1-2 digits. This is your key. That's nice. So how many combinations you are gonna make to achieve this key? So that's why I was saying it is not possible to decode it. It's just the certificate. Imagine, it is just the key, the public key. So that's how complex these keys are. And you should be very confident that nobody, at least with the quantum computers, cannot break it in at least 10 years. I mean, we cannot. I mean, after 10 years, maybe it will be broken. So that's why the key has a time period. Before, I remember when we were creating the keys, they were for 1 year. The public keys were valid for 1 year. Now the new policies are coming in, and they do not issue more than 9 months. And I heard that the policy is further changing, that maybe you have to renew after 3 or 6 months, because whenever the computing is growing, let's say, I mean, if they feel that it will be broken in, let's say, 6 years, so they say, okay, no, we should change key after every 3 months, because I don't know, maybe they think that there might be some supercomputer or supercomputer or quantum computing that can break the either algorithm or the key. So you have to continuously renew your key. So that's the Yahoo's public key. I can go to the browser again, and there is my browser. If I do view certificate, this is the certificate. Sorry, are you able to see the browser, right?
Yes, yes.
Okay. And so much information. The algorithm is there, the key size is there. It is 2048. If you want more encryption, you can increase the size of bits from 2048 to 4096. But whenever you are increasing the key size, I mean, this key will be encrypting or decrypting data, so your processing will increase a lot. So 2048 is pretty good as per today's standards. Maybe it not be valid for after 10 years. So key usage. The certificate authority is telling that this key can be used for digital signature, certificate signing, or CRL signing. And CRL, what are CRL? Certificate revocation list.
Dishan, I guess we cannot see that. The CRL.
Okay. How to? I think this one. Can you see it now?
Now we can see it. Yes.
Okay. So I was telling you, this is the high assurance certificate, and the certificate authority actually gives you a link to the CRL also. So CRL is like certificate revocation list. Let's say I have my private key available in my laptop. If laptop is stolen, it means I don't have the key available. So this key can be used for signing some data. So what I can do is I can go to my authority and I can tell them just the certificate is valid. The validity is maybe 3 more months, but I will put that document in revocation list, so that if my key is stolen, that certificate can be revoked and new certificate can be generated. So if someone is signing with that key, then that key will become invalid. So the certificate authority publishes the revocated certificates online, and whenever our solution, like web browser, is our solution. So whenever our browser is gonna talk to someone, it will verify the public key from the certificate authority. Plus, the browser will automatically check the revocation list if that certificate, if the certificate is valid or not. I mean, it is there in the revocation list or not. If it is if it is in the revocation list, it will pops you the error that the certificate is not trusted. So you can get so much information alongside with the certificate, but the most important thing is the validity of the certificate. That's it. I don't care anything else. The browser will take care of everything else. Let's go back to the presentation. And so I copied this. The certificate is packed in a standard which is X509. I mean, it is defined by, I don't care if it is defined by ITU or ITUT. It is the standard. And I told you the digital certificate revocation list and digital certificate life cycle. This is very important. Either you can renew or rekey. So the basic difference in renew and rekey is you can renew your existing key. If like you are saying that the key is issued for, it was valid for 3 months, you can say, okay, please add 3 more months to this key. So your key is renewed. But mostly this is not done. I mean, nobody allows you to renew your key because maybe you are renewing your key, you are giving hacker the more time that it can work on your keys or it can work on your data. So the good thing is that everybody nowadays, they do not recommend renew, they say rekey it, like generate a private and public key again, send us the new public key and we will sign it. So that is rekey and that is renew. So you should know the difference between the both. And our life cycle is complete. So I hope you get some of the PKI concepts.